So we're recording now. We'll see how this goes. Lesson 40.
Wait. I want to be in the recording.
Well, I'm sure you will be. Lesson 40 is, what is a reciprocal? We're talking about reciprocals. We're going to talk about solving algebraic equations using a reciprocal. And this is the start of it. Most of you would be able to tell me, I would think, what a reciprocal is. Can somebody raise your hand, please, Jake?
The opposite of my number.
Okay, I was at a wedding this weekend,
Wait.
and the guy doing the toast was a math guy.
Oh, was he good?
And he was talking about his sister marrying this guy, and when they first met and started dating, he thought, you know, they are opposites of each other. You know, so when you put opposites together, that would make 0, right?
Yeah.
And as they continued to date and continued to get closer to being at the point where they were going to get married, he goes, you know what, I had it wrong. They weren't opposites. They're reciprocals of each other. And when you take a reciprocal of a number times itself, that gives you a value of 1. Isn't that clever?
That's a nice word.
So, a reciprocal isn't the opposite, it is the flipped value of it.
It's
Yes,
the
sir.
same.
Whose wedding was it? Was it?
It was the wedding your parents were at.
Yeah, okay.
Is my mom there too?
Was
Yeah.
it this week? Yeah.
Gabe, Evans, and Tracy Shell. Okay, so 2/5 is the reciprocal of what? 5 over 2. Okay.
7 over
3/7 is the reciprocal of 7 over 3. 1/4 is the reciprocal of,
4 over 1.
which is just
4.
4. And 16 is the reciprocal of,
16 over 1.
that's what 16 is 16 over 1, and the reciprocal of that would be
1 over 16.
1 over 16. Okay. All right. The number 0 does not have a reciprocal. Okay. 0 is written as 0 over 1 as a fraction. So we can write 0 over 1. And I'm not going to go into it. But 0 over 1 is okay, but the reciprocal would be 1 over 0, and division by 0 is impossible. You can't have 0 in the denominator. I'm not going to go into why, you just can't. Okay? So there is no reciprocal for the number 0. Now, how are we going to use reciprocals? One of the things, let me go back and insert a page here. So, Scott, when he was doing his toast, said that when you take and multiply a reciprocal by its a number by its reciprocal, it gives you a value of 1. Let's look at that. We had, what was it? The number said 1/4. And if I took the reciprocal of 1/4 and multiplied it by 1/4, what would the reciprocal be of 1/4 first of all? 4 over 1. And if you multiply those, you get 4 over 4, which is 1. Okay? So a number times its reciprocal is 1. And that is extremely important to be able to help us to solve. Algebraically, that is. So 4x equals 12. We have talked, and I'm going to go over this 2 different ways, so don't get confused by the fact that there's 2 ways. Just figure out which way you like best and use it. We're going to solve this algebraically just like we are attempting to do when we have addition or subtraction between our value of x and our equals. Well, here, what's the operation between 4 and x? What's the operation between 4 and x?
Don't we do multiply?
It's multiplication, isn't it?
Yeah, but
It's an implied multiplication. So, like when we were doing the weights, if I added something, if I had, let's go back to this real quick. When I had x minus 3 equals 12, what did I have to do to solve for x?
divide. Take away.
We already are we have
No,
a
you have to
negative
even
3.
it out.
We need to even it out, but we need to do what with this negative 3?
Um,
If we think of it as negative 3, what do we have to do on a number line to get back to 0?
Add 3.
We had to do the opposite, didn't we? This was minus 3, so we added 3 to both sides to keep the balance. We used the opposite operation, or the inverse operation. If we have multiplication between our coefficient, the number with the variable, what do we do to undo multiplication? Divide. So we can divide this by 4, and as long as we do the same thing to the other side, divide the other side by 4, then we can keep that balance. What happens to 4 over 4? It goes to
1.
1, which is what we want. We want 1x. So we have x on that side equals
3.
3. And most of you would have known that answer was 3 without having to work it out. But you can divide those. Now the other way, and this is the way that I hope that most of you will go with, because if you learn this next way that I'm going to show you, then you can use this method to solve almost all of them. You don't have to memorize different situations and go, okay, in this situation I'm supposed to multiply, and in this way I'm supposed to divide. This is just going to show you how to do it every time the same way. And I'm going to go the long method of showing this, and then I'll show you where the shortcut comes in. So we have, I'm going to write this as 4 over 1x equals 12. I'm going to go ahead and put 1. Now, just like we talked about earlier, you have 4 over 1x, you have multiplication between those. So if we divide each of these, let's say I took 4 over 1 and divided it by 4 over 1. Okay. 4 over 1 divided by 4 over 1 would be
0.
No, 1.
It would be
1.
1.
Okay, so I'm dividing this side by 4 over 1. So I just get x. But on this side, if I divide by 4 over 1, then I have to apply my rule for dividing fractions, which is
KFC.
KFC. Keep the first,
Flip the second.
flip the second, change the sign to
Multiply.
multiplication.
12 over.
Then I can reduce 4 and 12 by 4. And then I get that x equals 3 times 1 is 3 over 1 is 3.
What happens if you don't
Here's-
KFC it?
Here's the shortcut. You have to KFC it. Then that is the shortcut. Rather than, what did I end up doing right here?
Multiply.
Multiplying by what?
By,
It's the reciprocal.
I ultimately ended up multiplying by the reciprocal. So wouldn't it have been easier on this problem if I had 4x equals 12 and I wrote them as fractions, just to start off by multiplying by the reciprocal? Because what's the value of the reciprocal times itself? 1. We just talked about that. And then we do the same thing to the other side. We skip a little bit here, don't we? These go to 1, or x equals, and then you can still reduce, and you get 3. Now, why would we write those as fractions if we didn't need to?
Because it asked for it.
If you want to learn how to do one procedure and not have to learn a couple different rules, then we write them as fractions, and we can apply this idea of multiplying by the reciprocal to solve. What's the difference between this problem here and this problem there?
one's
What's the difference between the problems to start with?
One's fraction and one is not.
I could write those others as fractions though. I could put 3 over 1. I could. What's different about the two problems? Just basically looking at it, what's different?
You do a lot more reducing in the other one.
What's saying, do I have a coefficient or a number with my variable here?
Oh no.
No. What I have here is two separate terms, and so I had to perform the opposite operation. Here I have a coefficient with the number. I'm still trying to isolate the x. I just have to do it by multiplying by a reciprocal or dividing by the number. Got to do that. Now let's get on, and so we can skip this so you can get to a little easier or see the point. Here's why we want to use this rule. I don't want to have to divide both sides by 2/3 and go out through the whole process. I want to get my y isolated. And to isolate my y, I'm going to multiply by the reciprocal of the coefficient of the value that's with the variable. Often students get turned around, they start multiplying by the reciprocal of that for some reason. But it's always the reciprocal of the coefficient, the number with the variable. So that way this all goes to 1y, right? Everybody agree with that? Because a number times reciprocal is 1. If I multiply the left side by 2/3, what do I have to do to keep my balance?
Multiply the right side by 2/3.
Multiply the other side by 3/2. I might have said 2/3. Sorry, if I multiply this side by 3/2, then I have to multiply the other side by 3/2. So then I multiply across. 1 times 3 is 3. 5 times 2 is 10. There's your answer. I'd rather you not put the 1 with the y. So y equals 3/10.
Do we have to put the y equals?
It's good practice to do it. It's not essential, but it's good practice. It's really simple when you multiply by the reciprocal. If you try to divide both sides, it gets lengthy. Alright. This problem looks different than the previous problem,
It means the same.
but it means the same. What's the coefficient or the number that is in front of m?
3?
No.
3 is below it, isn't it? So what's the number in front of m, Jonathan? That's what the answer is. But what's the number in front of m that we don't have shown here?
1.
1. Remember, there's one m here. If the m is by itself, think of that as being 1. Now you have the fraction 1/3. So what can we multiply both sides by to solve for m?
3/1.
Multiply by the reciprocal of 1/3, which is 3/1. So we do the same thing to the other side. You have
18.
m equals 18. So when you have that situation, just put a 1 in front of your variable, and that gives you a fraction that you can take the reciprocal of. Okay. Now, this one says solve by dividing. That's what we did originally. I have multiplication between these two. So I could put them both over 1s and multiply by the reciprocal. But since I have multiplication, to undo multiplication, I could just on this one just divide by 4. Divide both sides by 4 because 4/4 is 1. So you have x equals, and then 3/4 is 3/4. You could do that either way. Whatever way you're comfortable with, I'm okay. But if you're dividing on this one, then you're still going to have to know the other rule for multiplying by the reciprocal when you have fractions. Is that clear? See what I'm saying? So solve by dividing on this one. What are we going to have to divide by on this? Jake Bennett? 0.04. So divide by 0.04 on this side. Divide by 0.04 on this side. That leaves you with 1n equals, and then we have to divide 28 by 0.04. Move your decimal over 2 places, 4 goes into 28 7 times, and then you have a 0 and a 0, 700. Could you check that? Sure. Plug it back in and see if it works. Take 700 times 0.04 and see if it gives you 28. All right, that's the assignment. Problem set 40. 1 through 30. This is due Wednesday. Actually,
Thursday?
Thursday.
I think it's Thursday.
I'm really tempted to have it due tomorrow. I know you have a test tomorrow, but we don't have class Wednesday because we're going to Fort Scott thing still, as far as I've heard. No.
But then we have the
And
dance
so,
Thursday.
and then you have dance Thursday, so we want to have as much class time as possible.
But basketball starts today.
Yeah,
And a
well,
lot of people
maybe
won't
like
get home till
25.
like 6-ish.
All right, do Thursday.
Thank you.
Unless we have class for some reason, say the thing
Gets canceled?
with Fort Scott Community College gets canceled, then we will grade this Wednesday.
So we gotta be like watching the news and stuff.
Right.
just
Well, I just mean if it's
Make it.
if the plans fall through to where we're not able to go over for whatever reason.
What's the Fort Scott
We
thing
just gotta
for?
watch the news.
You're gonna get to go over and drive some machinery
You
and
get
mortar
a
bricks
mortar,
together.
yeah.
So, stuff like that.
Aren't there students teaching?
Yes. Like Drew Tersner. Drew Tersner was one of them that presented last year.
I gotta go to the restroom.
He graduated a couple years ago. So, yep, it's a pretty good experience. All right, let's see now what we have here.
Do you have fun there?